Good day and welcome to Mission Control Houston, where the team of flight controllers in Flight Control 1 is working on support for the crew aboard the International Space Station. Expedition 36 is made up of Commander Pavel Vinogradov, along with flight engineers Chris Cassidy and Karen Nyberg of NASA, Alexander Mazurkin and Fyodor Yushchin, who share the Russian Federal Space Agency origins of Vinogradov, and European Space Agency astronaut Luca Parmitano. All 6 of the crew members have been going through a very busy day of research activities, spacesuit troubleshooting, and a fairly major drill for emergency purposes. The troubleshooting continues on the suit that Luca Parmitano was wearing on Tuesday when he and Chris Cassidy stepped outside the Quest airlock for a 1 hour and 32-minute long spacewalk that was cut short from what had planned to be 6.5 hours after water collected in Luca Parmitano's spacesuit helmet and visor area. The team here in Mission Control, along with engineers in the background, are taking a very detailed and systematic look at what might have caused that problem. They are reviewing all the paperwork for the various suits that are on board the International Space Station to review all the testing and certification that was done on those spacesuits, which is extremely thorough. They also are doing a step-by-step look at the potential causes of what happened, which was that a significant amount of water collected in the helmet area of Luca Parmitano's extravehicular mobility unit. We can see those spacesuits as they are stored in the equipment lock here of the Quest airlock module. And so far, the team is continuing to do that step-by-step review. No definite cause has yet been identified. And their main job right now is to try to identify and make sure that this was a suit-specific problem, that it's not anything that is generic and might affect the other suits that are on board. There are enough suits and suit components aboard the International Space Station that should a major contingency occur that would require a repair effort outside the space station, after a thorough trade of the potential risks of the spacewalk versus the value of fixing whatever might have come up outside the station, we could possibly do a spacewalk, but there are no spacewalks planned immediately. All of the tasks that had been planned on Tuesday were important, but not of a critical or immediate need nature, and so those can be accomplished on a future spacewalk. Luca Parmitano today set up experiment equipment in the biolab rack. Karen Nyberg worked to set up a new fluorescent microscope that was recently delivered to the International Space Station. She was assembling the microscope components and setting them up for an initial checkout. The entire crew is also participated in a periodic emergency simulation drill. All 6 of them got into their respective Soyuz spacecraft. The mission control teams followed along and helped out and worked with them to identify the source of a simulated fire on board and to put it out. The crew members each retreated to their respective Soyuz spacecraft that you can see on that graphic. The expedition, the Soyuz crew for one of those vehicles, the Soyuz 34, would be Pavel Vinogradov, Alexander Mazurkin, and Chris Cassidy. And for the other Soyuz 35, at the bottom of the space station stack is Fyodor Yushchin, Luca Parmitano, and Karen Nyberg. After the drill was over, they resumed their normal duties inside the International Space Station and conducted a thorough overview. Is scheduled for a little bit later today to go over the results of that training session. All systems aboard the space station otherwise working very well, and we're anticipating at 12:15 p.m. Central Time that Cassidy, Nyberg, and Parmitano will be interviewed by KGO Television in San Francisco and WDAY Television in Fargo, North Dakota. Those will be on the media and education channels of NASA TV as other events are carried on the public and media channels, the public channel, and then we'll have replays of that event later on today in the public channel. This is live downlink television from inside the Quest airlock module, where crew members continue to work on troubleshooting and maintenance of the spacesuits and equipment that were used on EVA-23 on Tuesday. This view is a look at Chris Cassidy.
That were old and replaced by diapers that came up on ATV. And I understand the intent to keep these as a mag warehouse. There's 32 of them, though, and I was wondering if we could throw away half and just keep 16 of these.
We're checking, Chris. We may not have an answer right now, but we'll get one for you.
Okay, it's no rush.
Station Houston on 2 for Chris. What's the serial number of that bag that you're talking about?
Today on Mission Control, the team is being led by Flight Director Royce Renfrew. Anna Fisher and Kathy Bolt are at the spacecraft communicator console talking with Chris Cassidy.
There's no serial number. It's just a green mesh bag that holds diapers.
We copy.
Talking about some inventory management.
Are they all the same size?
I think it's half larges and half extra larges. Hold on, let me check.
Cassidy has located a bag of contingency waste containment devices. There are two different restrooms on board the space station, one in the U.S. side and one on the Russian side, essentially the same design to back each other up and also share the consumables. But there are backup methods for containing waste on board by the crew members, and Cassidy is asking if he can get rid of some of these because he thinks they've got more than they need to meet the unlikely need that they would have to use them. There's a look at the waste and hygiene compartment that's in the U.S. Portion of the International Space Station. It uses, again, a similar basic design set from the equipment that's used in the Russian segment of the space station. It provides a private place for them to take care of their personal hygiene needs. There's no shower on board, but a restroom is important, and it also gives them privacy to wash up, clean their hair, and do other things of that nature. The liquid portion of the waste is recycled through the space station's recycling system. And as the crew members are apt to say, yesterday's coffee becomes tomorrow's coffee. About almost 80% of the liquid waste on board is recycled and put back into use as drinking water or hygiene water for the crew members to use. It's collected both from the toilet systems and from the condensation that is recovered from the atmosphere as the astronauts breathe as they do their living and working aboard the space station. Here's a live look at Karen Nyberg in the Destiny Laboratory module, just around the corner from where Chris Cassidy is in the Quest airlock. She is continuing to work on a number of different experiment setup activities. She's working on an image processing unit, getting ready to replace a medium rate data link cable that's used to send imagery down to the ground from the different camera systems that are set up either for use by the crew members or through the experiments that are set up in the Window Observational Research Facility, which is just below her, that trains cameras for a variety of different experiments on the Earth below to document the condition of the home planet. The window that's an optical quality window that is in the earth-facing side of the Destiny Laboratory used to be one of the favorite viewing locations for station crews. However, now with the arrival of the space station's cupola, essentially a 360-degree bay window that's attached to the Tranquility module of the space station, that is the place the crew goes generally to do their photography, while the instrument cameras and imagery gathering devices are located in what is essentially the floor of the Destiny Laboratory module, where Karen Nyberg is taking pictures of this setup for the cable. Correction, Nyberg in the Japan Aerospace Exploration Agency provided Kibo Laboratory. It has similar blue coloring on one end of its pressurized module area, similar to that of the Destiny Laboratory module.
Otherwise, we will pick up with you on the other side.
Here's the Destiny Lab, and you can see the same blue color on the side of the wall. And then the salmon color of the Unity module, where Chris Cassidy is working because it's adjacent to the Quest airlock.
2.9.
It is a firm. I'm in step 3.2 right now.
And station, this is Munich for Luca. You are go to proceed. The valve is open. And we'll talk to you on the other side.
This is Mission Control Houston. We have temporarily lost our downlink signal from on board the International Space Station as we pass through one of those normal satellite seams where we don't have a direct link down to the ground below. Right now, the International Space Station flying approximately 250 statute miles over the Pacific Ocean on a northeasterly track. While we're out of communication, let's take an opportunity to hear from the Payloads Operations Integration Center at NASA's Marshall Space Flight Center in Huntsville, Alabama, which coordinates all of the research activity aboard the International Space Station. Not only that, designed by NASA and U.S. National Laboratory experimenters here in the United States, States, but also the activities of our international partners in Russia, Japan, Europe, and Canada. Today we're taking a look at a fluid physics investigation that's in the middle of a 40-day run of samples on the space station. Marshall Space Flight Center's Lori Meggs had the opportunity to speak with one of the researchers for the capillary flow experiment at the University of Bremen in Germany to find out more about this study. Let's take a look at that now.
Thanks. I'm here with Max Branowitzki, and he is from the University of Bremen in Germany. And Max,
Hello.
First of all, tell us about your experiment. What is your experiment?
Hello. So our experiment, capillary channel flow, is this is the project and experiment name, capillary channel flow, which is being conducted on board of the International Space Station. So this is the cooperation between German Aerospace Center, NASA, our University of Bremen, and Portland State University in America. So our project, capillary channel flow, we are basically interested in a fluid behavior in space in a compensated gravity environment, and in particular we focus on a fluid flow in a capillary channel. So just to give you an idea how does the fluid behave different on Earth and in space, I could give you an example. So for example, when we drive a car on Earth, we need a petrol. So petrol is stored in a car's tank, and due to the gravitational force, it stays on the bottom of the tank. It's obvious and simple to imagine. So it's pretty easy to collect the petrol from the bottom of the tank and transport it to the engine. But in space we have a bit different situation. There's no gravitational force which keeps everything on the bottom. So if we look at the spacecraft or if we look at the satellite, the propellant which is stored in a tank will not stay on the bottom. It will be spread, distributed everywhere inside of the tank. So it's pretty challenging to collect the propellant and transport it to the thruster. So there are some different devices which do the job, and such as vanes, which are basically capillary channels which we are investigating. What we do is a very fundamental science, very fundamental research. So we are trying to understand and describe the phenomena which were not investigated yet, and the propellant management system is one of the examples. But the other applications could be very generally fluid management in space, and not only propellant management system, but also life support system, and astronauts which live and work on board of on ISS. They use a lot of liquids. It's not only drinking water. And we are planning to go to the Mars, probably with a stopover on the moon. So we will need a lot of liquids, and we need to be able to manage them and transport them. So this is what our research about, but there are also some Earth applications, so such as lab-on-a-chip devices and a variety of microchannels used in a biomedical industry. So all microchannels where these capillary effects, which we are investigating, play a big role. And yeah, we've got some results, and it would be not possible to perform such a huge study here on Earth. And NASA gave us this wonderful opportunity to perform these long-term experiments in space, which is great. And you asked about the results, so right. I don't want to go too deep into the details now.
But you do have results.
Yes, but I would like to mention that there is a perfect agreement between the theory and our predictions and experimental results, which is great, and that gives us a lot of motivation for further work. What I would like to say that we really appreciate this help of NASA, and we do enjoy working with NASA together, and we are looking forward to do more experiments, and we do some real serious science, but we have fun, which is great.
That's
mainly
terrific.
thanks to NASA and MSG team. So
Terrific. And he's going for his PhD, so he's a candidate. So good luck with that too. Maybe this experiment will help that along.
thank you.
Thank you, Max.
All right, and a big thank you to Lori Meggs from Marshall Space Flight Center for that interesting update on research aboard the International Space Station. We're still out of communication through the tracking and data relay satellite system with the space station, although we do have some communication capability with the space station. The team here in Mission Control, led by Flight Director Royce Renfrew, continues to monitor all of the status aboard the station's systems. Everything's working very well, and one of the major items today continues to be troubleshooting for the spacewalk, the EVA-23 spacesuit problem that was experienced by Luca Parmitano. Everybody safe and healthy aboard the space station following that issue with the water intruding into his helmet and visor area, and a shortened spacewalk, planned 6.5-hour EVA becoming a 1-hour 32-minute EVA on Tuesday. The team here working fervently to determine the precise cause and to make sure that they've documented that well so that we can move on from here. We do have some additional recorded video from earlier today as Karen Nyberg did some experiment work. She's working with a new microscope system that was recently delivered to the International Space Station. This is going to be a fluorescent microscope system. Again, this is video that was recorded earlier today as Karen Nyberg, Expedition 36 flight engineer and research assistant aboard the International Space Station, was working with the setup of a new microscope system. This would allow fluorescent items to be looked at through the microscope, which allows additional investigations into a variety of different types of materials and plant growth and other experiments aboard the International Space Station. It's the initial setup of the instrument that was recently delivered to the space station.
To the station on Spacegram 2.
This is Mission Control Houston. While we're out of TV coverage with the International Space Station, taking a look at some activities going on nearby here at the Sidney Carter Training Facility in the Neutral Buoyancy Laboratory, where astronauts Mike Hopkins, who's scheduled to go up to the International Space Station on Expedition 37, and Astronaut Office Chief Bob Behnken are going through a simulated spacewalk to prepare Hopkins for any potential spacewalking activities aboard the International Space Station during his expedition. Yesterday, Hopkins was a member of the trio of crew members that was part of a preliminary crew news conference looking at the upcoming mission of Expedition 37 and 38. He'll be going up to the International Space Station along with Oleg Kotov and Sergei Ryazanskis. and they'll be spending about 6 months aboard the International Space Station, continuing the continuing human presence aboard the orbiting outpost that's been going on since the year 2000. Again, this is live video from underwater at the Neutral Buoyancy Laboratory as Mike Hopkins and essentially his boss, Bob Behnken, practice spacewalking activities inside the space station mock-up of the underwater area. This simulation uses a technique called neutral buoyancy, in which the astronauts are weighted such that they neither float nor sink. It's a pretty darn good approximation of what it's like to work in microgravity outside the International Space Station. Some minor differences. You've got some water resistance that you have to work against, which would not occur in microgravity, and the blood still rushes to your head if you go upside down, and so they tend to arrange these spacewalk simulations so that that is limited. Here clearly one of the spacewalkers is in that situation. And then, of course, any of the hardware that crew might be moving around for the spacewalk would be weighted so that it's more massive and yet doesn't weigh anything, just like things do in space, so that you get a good feel for what it's like to move those big objects around. Of course, there are safety divers there to assist with keeping the simulation realistic and also making sure that the crew members stay safe while they're underwater. These are essentially the same spacesuits as they would use outside the International Space Station, with the exception that instead of the backpack that provides cooling and airflow for them, they use underwater delivery lines that use oxygen, atmosphere, and liquid cooling capabilities that are driven hardline into their systems instead of trying to maintain the backpacks for underwater use. And back now with live television from aboard the International Space Station as we've regained our signal from the International Space Station through the Tracking and Data Relay Satellite System, as astronaut Karen Nyberg continues her work in the Kibo Laboratory. She's working right now with a replacement cable for a medium rate data link cable that's associated with imagery downlinks and recording aboard the International Space Station. This particular one associated with the Ryutai rack in the Japan Aerospace Exploration Agency's Kibo or HOPE laboratory. One of three major laboratories aboard the International Space Station. It joins with the European Space Agency's Columbus Laboratory and the United States NASA Destiny Laboratory to provide the majority of the research facilities aboard the International Space Station. It's interesting that the different experiment racks are interchangeable so that they can fit within any of the laboratories. So you might have a German experiment in the US laboratory and a French experiment inside the Japanese laboratory, and a US experiment inside the Columbus laboratory at any given time. And they interchange those as needed to respond to the power and data requirements and the space available to conduct their different work aboard the International Space Station. Something like 200 experiments going on aboard the space station at any given time as the crew members seek to have about a full 40-hour work week's worth of experimentation accomplished every week aboard the orbiting outpost. Of course, all this done as the crew maintains the space station and conducts all of the necessary exercise and to keep their bodies healthy, so that they can both accomplish the work on orbit and that they'll be able to be rehabilitated quickly and well when they return to one gravity of Earth after their what is a typical 6-month expedition to the space station. Microgravity Life can reduce your bone and muscle density, and it's been found that serious exercise, about 2.5 hours every day for each crew member, along with a prescribed diet, which is still being tweaked a little bit, can help minimize those potentially detrimental effects of long-duration stays in space. Right now, the space station orbiting about 250 statute miles directly overhead of the United States. As this particular orbital track is taking the station from the Pacific Northwest and the Seattle area across the northern section of the U.S.'s Midwest area. Karen Nyberg hails from Minnesota and North Dakota, so she's flying right over home and missing a chance to look out the window at the Earth below because she's busy with other experiment work. This actual track will take the space station over the eastern seaboard of the United States before it heads out over the Atlantic Ocean and the eastern tip of South America. The Ryutai experiment rack that is the subject of Karen Nyberg's work is a fluid research rack. Ryutai means fluid in Japanese, and it's a multi-purpose payload rack system that includes a fluid physics experiment facility, a solution crystallization observation facility, a protein crystallization research facility, as well as the associated image processing for those experiments, which is what Karen Nyberg is working on right now. Ryutai, which is provided to the station by the Japan Aerospace Exploration Agency, provides a bunch of simple standard interfaces that accommodate modular payloads. It can operate up to 4 sub-rack facilities, and it's housed in an international standard payload rack. That's a refrigerator-sized container that we mentioned earlier is being interchangeable throughout the space station, and it can be divided into several different segments. The Ryutai rack uses standardized hardware and interfaces, a streamlined approach that enables quick, simple integration of multiple facilities aboard the space station. Each rack, such as this, can be divided into several segments as large as half the entire rack or as small as a bread box. Ryutai was launched to the space station on the STS-123 space shuttle mission.
And Luca, we copy all.
And you can go ahead with step 4.1, and then I'll complete the procedure.
As we continue to look at Karen Nyberg in the Kibo laboratory module, the Japanese laboratory, you can also see through the Harmony module pass to the Columbus laboratory, where Luca Parmitano is in the process of working on some water sampling activities.
Has been closed.
Crew members periodically retrieve samples of the water within that laboratory and collect pH samples for testing and making sure that the internal thermal cooling system water is at the proper levels. That is a water-based cooling system that is used to help get rid of the excess heat generated by all the electronics that run the various experiments on board the space station. And the water-based system is used in the crew habitable areas so that if there were to be any kind of a leak, that it wouldn't be a health hazard to the crew. And it goes through a heat exchanger outside the space station, and then it transfers its heat to an ammonia-based system, which is much more efficient way of moving heat around out in microgravity and in space. And then that flows through the large radiators that are on the International Space Station and is ejected into space through that ammonia-based system. So periodically you want to check that internal thermal control system's fluid to make sure that it's got the right levels of the chemicals that it needs to keep it from becoming contaminated so that it can keep circulating through all the different pumps and lines that keep that module cool. Here's another look at Chris Cassidy as he continues to work with equipment inside the equipment lock portion of the Quest airlock module. That is the staging area for spacewalks, and he's working through some procedures at this point. That are associated with restowing of items that were brought out in support of the Spacewalk 23 on Tuesday. Of course, that spacewalk was shortened from a planned 6.5 hours to about an hour and 32 minutes. Cassidy and Luca Parmitano were able to accomplish just the first two tasks on their schedule before Luca Parmitano experienced a problem in his spacesuit that led to the accumulation of water in his helmet. And so they had to do an immediate end to that spacewalk and get everybody back inside so that we could get the spacesuit off and ensure the health and safety of the crew. Everybody that was involved in that spacewalk reported to be doing very well following those activities. And in today's International Space Station Mission Management Team, partners from around the world praise the efforts of the team to bring a swift end to that spacewalk when the problem was identified. Especially the European Space Agency representative, thankful for the entire team's support for Luca Parmitano and reporting that he's doing very well. Troubleshooting continues on these spacesuits, Luca Parmitano's in particular. But the first order of the day is to try to identify the specific cause for the problem that led to his discomfort in the spacesuit, and then to identify whether that is a problem just with that spacesuit or whether there is a potential for it to extend to other suits that are on orbit. There are multiple suits on orbit, and if we were to get into a contingency repair situation outside the station, if the risks of not fixing whatever broke were great enough, we could potentially do a spacewalk. But for right now, we're focusing on the identification of exactly what happened on Tuesday, trying to make sure that we know precisely what occurred, reviewing all the paperwork for that suit, and working up troubleshooting procedures that are expected to continue tomorrow to try and isolate the problem inside that suit. And then once we do that, it'll allow the team to go off and compare data on that suit to the other suits and potentially do additional troubleshooting on those suits to verify that they're ready to go before we decide to try and mount a spacewalk to complete the tasks. The tasks that were not completed on Tuesday spacewalks are important, but they're not of an urgent nature, and so they can be put off until the team has had a time to do its due diligence and work through these troubleshooting procedures and identify a way to deal with whatever happened on Tuesday. While activities continue aboard the International Space Station, the second annual International Space Station Research Conference continues, hosted by the American Astronautical Society in Denver, Colorado this week. Tuesday through Thursday conference in which investigators from around the world gather to talk about the various experiments they are mounting and to compare and contrast the results that they've been obtaining through the experiment activities aboard the International Space Station, some of which involve crew involvement and some of which are automated experiments. We're looking forward shortly here to having a live interview with one of the participants for that conference. We've got Dr. Kathleen Morse of Advanced Materials Applications. She's a recent award winner of the Center for the Advancement of Science in Space Materials Science Program. She's usually utilizing the NanoRacks external platform to conduct her experiment.
Munich Columbus, Luca on 2. I'm completed step 4, decimal 14 and 15, so you can open ISTR02.
And with that, let's go directly into our interview. Welcome, Dr. Morse, to Space Station Live.
Thank you. Thank you for having me.
Well, so tell us a little bit about your experiment.
Well, I'm studying gum sticks in space. There's currently a need for terrestrial computing power in space, and we're hoping to evaluate these gum sticks to see if we could use them in fault-tolerant space computers.
And I think we have a picture of one of these gum sticks that we can show. Can you tell us, this is the one I believe with the fingers holding it so you can see the size. Tell us a little bit about what we're looking at here.
Yeah, it's a tiny computer. It has digital signal processing. It has a CPU, and it has a graphics processor on board. And so basically, it's a very powerful, tiny computer. And it's about 2 to 3 generations, ahead of a lot of space-qualified computers. So it's very attractive to using this kind of processing technology in current space missions and future space missions.
We can see the size of it here. How much does it weigh?
It weighs about 4 grams. It's about the size of a stick of gum, literally.
So that's why you call it a gumsticks computer. What kind of
That's right.
applications would you use this kind of computer for?
Well, it will have a very high processing density, so it's ideal for computationally demanding tasks, such as signal processing and analysis, data capture, and sensing and detection. So it's ideal for a lot of NASA's current and future space mission needs.
Have you had a lot of interest from your colleagues that are at the second annual Space Science Conference in Denver?
I have. A lot of people see the need to move away from the space qualified computers, especially for missions in LEO where the radiation environment is not too extreme. And it's also a much more cost affordable solution. So it's a pretty exciting advancement.
And so clearly by being able to have computers this small and this light, you're going to reduce the cost of some of the research aboard the space station. I'm sure that's an exciting potential for researchers that are trying to design their research for things like nanoracks, where we try to minimize the size but maximize the capability.
Absolutely. It's also very exciting for CubeSat satellites. You could potentially have a CubeSat that's a very powerful satellite.
And a CubeSat is a very small, smaller than a breadbox satellite that can be ejected from the space station and conduct independent research.
That's right. They tend to be about 10 centimeters on the side, and these gumsticks are very, very compact, about 10 centimeters by 2 centimeters, and they can be stacked on top of each other, so you could potentially put a large number of computers on one CubeSat form factor.
Are there any Earth-based applications for these kinds of small computers?
Yeah, for applications where you need the reliability of a fault-tolerant computer and something that can withstand potentially a radiation environment, such as a nuclear facility.
All right. Well, Dr. Morris, I'm afraid that's about all the time we have today. We appreciate you taking time out from your busy schedule at the conference, and we wish you well, and thanks for sharing the information about these gumsticks computers. They look like an exciting development for future station research.
Thank you. We're excited too.
Thanks again. That was Kathleen Morris, who is with Advanced Materials Applications. Thanks for joining us here on Space Station Live. This is Mission Control Houston. We are continuing to monitor the status of the International Space Station as it orbits off the eastern tip of Brazil and South America on a southeasterly track at an orbit of about 250 statute miles. Much research continuing aboard the International Outpost as Expedition 36 Commander Paul Vinogradov, flight engineers Alexander Mazurkin, Chris Cassidy, Fyodor Yashikin, Luca Parmitano, and Karen Nyberg continue their work aboard the orbiting outpost. A reminder that coming up in a little bit more than an hour, we're going to have an in-flight interview opportunity as KGO Television in San Francisco, California, and WDAY Television in Fargo, North Dakota have an opportunity to ask questions of Expedition 36 flight engineers Chris Cassidy, Karen Nyberg, and Luca Parmitano. That event is coming up at 12:15 p.m. Central Time, and we're looking forward to good questions there. We'll be back again tomorrow with the latest update on the activities aboard the International Space Station on Space Station Live at 10 a.m. Central Time. This is Mission Control Houston.